Okay, so today in class you guys were working on 2-6 on a group assignment, and I know you only got through about the first question, so I wanted to talk to you about how to do problems 85 and 87, and I'm going to do problem 86 as your example, okay? Really, I think I should have had you start here today. I think class would have maybe gone a little smoother. You would have felt a little more comfortable with the graphing if we had started with 85 and 87 and then backtrack to 81 to 84 maybe on Wednesday. But anyway, this is where we are. So we are supposed to take our function and rewrite it as a quotient plus a remainder over a divisor. This is what your directions say for this problem set, like 85 to 88, I believe, in your textbook for 2-6. All right, so here's 86. G of x equals 3x plus 7 over x plus 2. And you can look at this and you can know what the vertical asymptote is. You can know what the horizontal asymptote is. But I want to talk to you about how to graph this by rewriting it in this form as a quotient plus a remainder over a divisor. Okay, so basically, back in the first part of the chapter, 2-4, we would have been asked to divide these two, and that's what we're going to do right now. Long division or synthetic division is fine. For this one, because we're dividing by 1x to the first, synthetic is going to be the more efficient method. So that's what I'm going to do. My top row has 3 and positive 7 as the coefficients of our numerator, and then we're dividing by x plus 2 so that that root that we are dividing by is the negative 2. Okay, this is going to look like a very short version of synthetic division, and it is because this is a linear over a linear. Okay, so we're going to bring the 3 down under, and then multiply, and then bring those together. Okay, so the quotient and the remainder over the divisor. Okay, so here's how we're going to write this. The 3, remember, is 1 degree less than what we started with. So this was a linear, 3x to the first. Our 3 is actually just 3, no x's with it. And then the 1 is our remainder. I know you can't see that because of my head, so let me scroll down. Okay, so in the synthetic division, the 3 is now this big constant number. And then the 1 is positive, so we're going to say plus 1 over x plus 2. Remember, we always put our remainder over what we divided by, and that was x plus 2. Okay, so now let's talk about how to graph that using transformations, which is also what it says. Instead of writing 3 plus the fraction, I'm putting the fraction plus 3. That's the way you saw it in the first homework assignment towards the end of that first individual assignment on Math Excel. All right, so using transformations, what we are going to do is take a look at the parent graph, y equals 1 over x, with a vertical asymptote of x equals 0 and a horizontal asymptote of y equals 0. I could have extended this branch, I just didn't have enough room on the board when I was drawing this out. But we have the parent graph, and then we need to talk about how do the plus 2 and the plus 3 translate that function. Okay? So the plus 2, remember this is a number that has been added inside the function. What I mean by that is it's inside the fraction and it's next to the x. That causes a horizontal shift. It's actually going to cause us to move the graph to the left 2 spaces. Okay? So I've just taken the parent and I've shifted it left 2 spaces. Adding inside a function causes a horizontal shift. Okay, you may have been in the camp saying, I know the vertical asymptote is x equals negative 2 because a negative 2 would make the denominator 0. You would be right. All right, so we've shifted left 2. Now this plus 3 adding outside causes our y, all of our y's to shift up 3. So here's up 1, up 2, up 3. Okay, sorry that this is not a very straight red line, especially right there. So here would be the graph of our g of x. It started off as 3x plus 7 over x plus 2. And now we have rewritten it as 1 over x plus 2 plus 3. And that allows us to graph it with transformations instead of going through that 7-step or 3-step process as I condensed it to. Okay, the horizontal asymptote, just to go over that really quickly, this right here is bottom heavy. Bottom heavy means a y-intercept, or I'm sorry, a horizontal asymptote of y equals 0, which is your x-axis. But the plus 3 takes the y equals 0 and makes it y equals 3. So it shifts the asymptote up 3 as well. Okay, so let me break down the homework that's going to be due. Okay, the Math Excel, our first homework assignment, is actually due Tuesday morning at 8 a.m. That's when the program will stop accepting submissions. Anything that you've completed up until 8 a.m. will count, but if you don't start this until tomorrow morning, you're going to have a problem. Today's group assignment, this says 82, 84, and then 85 to 95 odd. I said at the end of class, I think I said 81 to 95 odd. If you already did 82 and 84, don't go back and do 81 and 83, okay? 85 to 95 odd, you might want to leave off 89 until after we do the individual assignment here. And this isn't, I think, it is definitely 8 problems, 1 through 8, and that is going to be due Thursday morning at 8 a.m. And then the second group assignment, we're going to work on just 5 problems on Thursday in class, and that's going to be due Thursday in class before you leave. Okay? All right, let me know if you have any questions. Sorry I took so long.